What's up, scholars? Today we're going to find the equations for the polynomial functions if we're given their zeros. So a couple things to define just before. Polynomial. You have a basic idea when I say the word polynomial, what that is. But a polynomial, just to define it a little further, you all know what my favorite polynomial is. It's my favorite function, and that is the function y equals x squared. This is a polynomial. All polynomials are nice and smooth. They have no domain restriction, which is awesome. They can come in all powers of your independent variable here. So like, for example, you could have something that looks like now the highest power of this polynomial in my leading term has a power of 4. So you already know this is going to be facing up, and it's going to have how many bends? About 3 bends, right? Because it's going to be one less than the highest power of x. And this guy is going to have zeros, right? Or roots or solutions. So zeros are also called roots of the function, and they're also called solutions, right? And they're wherever the graph just touches the x-axis. So I don't know, my x-axis could be here. And then in this case, this polynomial would come through and touch it 1, 2, 3, 4, right? It crosses 4 times. But my x-axis, I'm not quite sure where this guy is. This is like +7, so I kind of moved it up a little bit when I was making this up. Maybe not the best idea. It could also, my x-axis could also be here, and it actually touches 1, 2, or crosses through 2 spaces, but then it only bounces right there, right? And then it just has 3. If that's the case, it's actually going to have imaginary solutions as well, right? And if it's all the way, if the x-axis is all the way down here, then this thing doesn't look like it ever touches, but we've learned this week that given imaginary numbers, this thing is going to touch, or it is going to cross through as well. So this actually leads us to the fundamental theorem of algebra. Also known as FTA. So FTA. Here we go. Fundamental theorem of algebra says a polynomial of degree n has n complex roots. Roots also known as zeros. These can be real and non-real. And some may be repeated. So, and what do I mean by this? The degree n is always going to be your highest power, right? So here in my example, my degree is 4. So for this example, I'm going to have 4 complex zeros. I'm going to have 4 places where this function either crosses the x-axis, imaginary or real, or it bounces off the x-axis. And we're going to look at the differences between crossing and bouncing. But for now, all we need to do is find the function for any polynomial given its zeros. Let's just think about what we've done before, right? I've given you something Like an example we did this last week was x squared minus 9, right? And I told you to find the zeros of this. Where does it cross the x-axis? Well, what you did was you factored this. And remember, this is a difference of squares, so I can really easily, I can think about this as x squared minus 3 squared. And I can just go, oh, my factors are going to be x plus 3, x minus 3. And so to figure out where this crosses the x-axis, you set it equal to 0. You use the zero product principle and say, okay, either this one equals 0 or this one equals 0 or both. So then I'm going to solve for x, and x equals 3 in this case, and x equals negative 3 in this case, and x equals positive 3 in this case. And there are answers. It's going to cross the x-axis at negative 3 and positive 3. And we looked at a picture of that. So now what we're doing is you're going to do this backwards. You're going to start with the zeros. Given the zeros, you are going to find the function. You're going to find that. So what we're going to do is we're going to take these and we're going to plug them in to the factored form. We're going to find the factors. Notice, if this is x equals 3, I have to switch the sign when I put it in here because the zero product principle, that's going to switch that positive. I need to plug in a positive 3 to get 3 minus 3 equals 0, right? So whatever you're given for a 0, you always just switch the sign when you write it in factored form. Then we're just going to FOIL this out, and we're going to get back our function. Super, super simple. All right. So let's say I've given you the zeros 3, 0, and 4, and I want you to find the polynomial. That O turned out a little larger than expected, but that's okay. So what you're going to do is you're going to write this out in factored form first. You're going to say, okay, x minus 3, because if that's positive, I'm going to switch the sign. X, well, I could write minus 0. I could write positive plus 0. I don't know. What do you think? Is 0 positive or negative? 0 is evil. That's what it is. And then if that's a positive 4, I'm going to make it minus 4. And then I'm saying to myself, okay, this crosses the x-axis when y equals 0. Because when y is 0, I'm on the x-axis, right? So now to find the formula for this function is I'm just going to FOIL this out. Now you're used to doing just 2 at a time, but it's really easy to do 3. You are going to have to do the 2 at a time first, and then you just multiply everything that you got by the last one, right? So I'm actually going to skip this one for now, and I'm just going to multiply these two together. And I am going to get I'm going to do my favorite way of multiplication. You can totally use FOIL. You can totally use the box method. But I just find that when I stack them on top of each other, I'm going to put my side work over here. When I stack them on top of each other, that's just really easy for me. Oh yeah, obviously, pause the video, see if you can do it. Okay, so now I have x minus 0 times all this other stuff, which really just equals this. Perfect. So now really easy way to do this would just be, you would say, okay, I'm gonna basically do the FOIL method, except I just have one extra term. So I'm just gonna do x times all three of these, and then I'm gonna do 0 or negative 0. Is that a thing? I'm gonna do 0 times all three of these. Now you can see automatically 0 times all this stuff is just gonna be 0. So I don't need to like add that stuff on and like combine all of those like terms. I'm just going to do x times everything, and then I'm done. And boom, there it is. Set it equal to f of x, or if you prefer, set it equal to y, however you want to do it. But that is the function for this polynomial that crosses through at x equals 3, x equals 0, and x equals 4. If we were to go back through and factor this again, we'd get this back. And then using the zero product principle, we would get x equals 3, x equals 0, and x equals positive 4. And a good check for this too is to graph this on Desmos. Does it actually cross there? You could as well make up your own zeros and then find your polynomial, right? All you have to do is put in the factors.